Okay, part two, whatever, of part two of recognizing linear relations. So you would have done some assignment questions, and now it's time to move on to a bit more application, a bit harder problems. Okay. In this question, it's saying, let's see, consider these frames, and a frame is like this box right here. Really, it's just a square, and every side is equal. Okay, and in this one, this frame has a side length of 1, and that could be 1 centimeter, 1 meter. We're just going to call it 1. This one is a square where every side length is 2. And this third one, frame 3, excuse me, is every side length is 3. Okay, so just so you understand basically what we're looking at there. And in the next one, it asks us to fill out a table of values, okay, for the frame number. So this becomes our independent, or our x, right? We have our x right there. And here's our y. And we're supposed to list the perimeter right here. Okay? So if we look back, and for frame number 1, we want to find the perimeter. Well, the perimeter is side plus side plus side plus side. So it's going to be 1 plus 1 plus 1 plus 1. So for the first frame, frame number 1, the perimeter is going to be 4. I'll write that down. Perimeter equals 1 plus 1 plus 1 plus 1. Okay? Or 4. So that's what you fill out in the table of values. Here, the perimeter is going to be 2 plus 2 plus 2 plus 2, or 8. And here, it's going to be 3 plus 3 plus 3 plus 3. Oops. Oops. So let's fill out the table of values, at least with the information we have. Oh, that was going to be 12, right? Equals 12. So let's fill that up in our table of values. The perimeter of the first one is 4. And in the second frame, it was 8. And in the third one, it was 12. Now, we don't know 4 and 5, though, really, there's two ways you could fill this out, right? We could say, okay, just draw a box and say, okay, what if every side length was, because 4 would have side length of 4, right? We could figure it out that way, and 5 would be side length of 5. And you could do that, and let's just say then perimeter of this one would be 4 plus 4 plus 4 plus 4, which would be 16, right? So for frame number 4, if I had a picture of it, I'd have 4 here, 4, so it would end up being 16, right? So we know that's true, but I'm not going to write that yet because I'm going to show you another way to figure it out. Using the data that we had originally, we had 3 boxes, and then we can do first differences. The first difference there is 8 minus 4, which is 4. This one is 12 minus 8, which is 4. So right away I say I have 2 first differences that are the same. So really, I could use, I could say, for example, that it's linear. That's my guess. And if it's linear, then I want to figure out this one. Well, if the difference is always 4, like goes 4, 8, 12, the next one's probably 16. Of course, we know it's 16 because we figured it out here. And without going through this process, right, without doing this, we could probably guess the next one is going to be adding another 4, 20. So that's one of the benefits of working with first differences. You can figure out the relationship between the y values, and you can extrapolate. Extrapolate just means continue with it. Okay, so yes, it's linear because our first differences were constant through the 2 that we had. Okay, so we filled in the table of values. That's done. Fill each table of values for the frame number and use the table of values to determine it's linear. Done. Okay. Now the next one refers to the same. This time we're looking at area. Well, remember that area is side times side. Right? So for this one, the side length was 1, so the area is going to be 1 times 1, which is 1. And this one, it's going to be 2 times 2, which is 4. Right? So this one had a side length of 2. This one had a side length of 3, so it's 9. This one has a side length of 4, so 4 times 4 is 16. And this one was 5, so 5 times 5 is 25. Because really, right, the frame number is the same as the side length. In this particular question. Right? So first difference is this time, 4 minus 1 equals 3. 9 minus 4. Uh-oh. 9 minus 4 is 5. I can stop. This is not linear. I could keep going if I wanted to, but I know right away, not the same, not linear. And that's often the case. Area is not a linear relationship very often. Okay? Okay, another one. So this time, just so you understand the question, this one as well is this length here is 1. So the length of each little box on this one is 1. So let's maybe work out our perimeters and areas out here. So if I said perimeter of this one is 1 plus 1 plus 1 plus 1, it's 4. Area is 1 times 1, right? Length, because that's 1 as well, so length times length, so it's 1. And what that tells me is that each box has an area of 1. So for this one, I'm not going to, do some calculation. I'm just going to say the area. That's 1, that one, and that one. So perimeter of this one is, let's see, 1, 2, just add it up, 3, 4, 5, 6, 7, 8. Perimeter is 8. Right? Because we know each side length is 1, we just count them up. The area is just count them, 3, right? 1, 2, 3. Perimeter of this one, same thing, just count as you go along. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And area, just count them up. 1, 2, 3, 4, 5, 6. Okay, and this one, this is a big one, but we'll just go counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Perimeter is 16. Remember, by the way, I'm only counting the outside. I'm not counting any of the inside lines for perimeter. It's always the outside edge. And areas, count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 7, 8, 9, 10. Okay. So we'll have to add these to our table of values. 4, 8, 12, 16 for perimeter. I can tell already its first differences are constant, right? It goes up by 4 every time. But let's write it in. 4, 8, 12, 16, and I think I can, did we do? We had 4, right? Well, we can, oopsie. We can guess the next one, right? I've got to hand myself. Because 16 is going up by 4 every time. 4, 8, 12, 16 must be 20 for 5, right? And my first differences are 8 minus 4, which is 4. 12 minus 8, which is 4. Right? First differences are constant at 4. So I made the assumption that the first differences here would be constant as well, which you can do. Okay? So that's my first differences, and so it's definitely a linear relationship. And on the next one, area. So let's go back and get our data. Area is 1, 3, 6, 10. 1, 3, 6, 10. Let's write it in. 1, 3, 6, 10. Now, look at this. First difference is 2. First difference is 3. First difference is 4. So, not constant, not linear. Now, if we wanted to fill in this table, though, I wonder if we could make a guess on what happens. See how it goes up by 2, then up by 3, then up by 4. I'm going to guess the next first difference is 5. So the next point is going to be 10 plus 5, or 15. And I'm going to make a guess that the next one goes up by 6. So this one's going to be 15 plus 6, which is 21. That's just a guess. But based on what we've seen here, that the first difference increases by 1 every single time, it's probably a good educated guess to say that those follow that same pattern. And so analysis here, when it says analysis, it just means explain what you found. And so we found that with perimeter, the first differences are constant, which is a linear relationship. Areas, not linear. And that's very typical, and you can expect to see that. Okay? So I'd like you to work away at the next assignment questions. It starts here. Looks like what we just finished, right? An area. You can probably guess if you think it's going to be right away. Guess if you think it's going to be linear or not. But you're going to work on this until you see the note that's called 6.2. So you're going to work until you see... Oh, no. Actually, I lied to you. We got more to do. So we have another little lesson to do involved in this one. So you're going to do this until you see this example right here. Okay? Until you get to that point, and we'll do another video for this point on.